Hello, we will be starting with the session now. Dear authors and invited guests, welcome to Technical Session 8A. My name is Dimahi and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, Bangkok, Thailand. The 11th edition of the conference is being organized in a hybrid mode. The physical event will be held today in Bangkok, and the virtual event is being held through Zoom from 9th to 11th April 2026. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for presentation and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Now, before we start with the presentations, I would like to introduce you all to the chair of the session. We will have with us Dr. Prashant Maharudra Suryavanshi, who will be joining us in some time. And we have Professor Reena Satpute. Professor Reena is an assistant professor at the Faculty of Science and Technology, Datta Meke Institute of Higher Education and Research, Maharashtra, India. Her research areas include data science, computer applications, and emerging computing technologies. She actively contributes to the academic community through scholarly publications, authoring technical textbooks, and participating in international engineering and research associations. I welcome you, ma'am, and I request you to share any introductory remark you may have for the presenters today.
Okay, thank you, Dimahi. Thank you very much for this nice introduction. So here, a very warm and pleasant good morning, good afternoon to all the delegates, distinguished speaker and participants joining us from across the globe. I am Professor Reena Satpute, Assistant Professor, Datta Mege Institute of Higher Education and Research, Savangi Meghevarda. It's my great honor and privilege to welcome you all to this technical session of 11th International Conference on Information and Communication Technology for Intelligent System that will be held on April 9 to 11th, 26 in Bangkok, Thailand. Although we are connected virtually, but this platform provides us with an excellent opportunity to come together as a global community of scholars and professionals to exchange innovative ideas and discuss emerging trends in information system and business management. So that whatever inventions we will be doing as a part of research and innovation, so hopefully that research will be helpful to support the humanity and kindness across the globe. So, as a session chair, I look forward to facilitating a session filled with insightful presentations and meaningful discussions. So, here I encourage all the participants to engage actively, ask questions, and contribute to this knowledge sharing spirit of the platform provided by GR Logistic Foundations today. So this will be a sharing speech from my end, ma'am. Thank you very much. And at last, I would be very much thankful to GR Foundation for giving me such an honor and privilege to serve as a session chair for this renowned conference. So thank you very much.
Yes, thank you very much, ma'am.
Yeah.
Now we will be starting with the presentations. I
Yeah,
would like
sure,
to
ma'am.
ask Morveen Bamania to present their study on a review on framework for detection and prevention of email phishing attacks. Morveen, sir. I repeat, Morveen, sir, or any of the co-authors of this paper. Tevin Moodley. Tevin, sir, are you present? I repeat, Tevin or any of the co-authors. Akdas Hassan.
Yes, I'm here.
Yes,
Agdas
ma'am,
Hassan.
please. Please present your paper on automated generation of high-level architectural diagrams from embedded system code using explainable AI.
Sure thing. I'll be sharing my screen. Please let me know when it's visible.
Yes, ma'am, we can see your Zoom screen currently.
Uh, can you see my presentations now?
No, ma'am, I see your Zoom screen.
Yeah, does it show automated generation of high-level language? I have shared my presentation right now.
No, ma'am, we cannot see your presentation.
Let me share it again. Is it visible now?
Yes, ma'am.
Okay, so hello, this is Agdas Hassan, and today I'll be presenting my work that is automated generation of high-level architectural diagram from embedded system code. So this work has been carried out under supervision of Dr. Farooq Azam and Dr. Wasim Akram Anwar, and we are from National University of Sciences and Technology from Islamabad, Pakistan. So the agenda of my screen is as flashed on this screen. I'll be briefly discussing why automated generation of high-level architectural diagram is important, limitations of existing research, my proposed solution results, and the future directions. So, understanding embedded system is not just about reading the code. It requires a clear view of the system, as the embedded system are used in very critical situations, and Mm, it is used in safety critical and resource constrained environment. So, however, in most cases, embedded system code is written in C, C++, or assembly language does not explicitly captures the high level information of architecture. So, traditional reverse engineering tools can extract technical details like call graphs, dependencies, but they fall short when it comes to provide a meaningful high level architectural view, and also they do not explain why a certain module are connected or structured in a particular way. So this lacks transparency and explainability and becomes a major limitation, especially in safety critical systems where developers need to fully understand and trust the system's design decisions. Now let's look at how architectural recovery has evolved over time. So, in my literature review, starting with the early foundations, systems like Quorum 2 provided systematic ways to relate low level source code to high level architectural diagram. But this approach required a significant manual effort and were not scalable to large or complex embedded systems. And next was the tool based recovery systems. The tools such as DALI and Armin were focused on visualizing architecture from the core dependencies, but they mainly relied on static analysis and lacked interpretability, like in the Quorum 2. So they focused on static analysis and only general structural views without explaining the reasoning behind the module relationship. Moving towards the AI based approaches, SARIF was an improved architectural recovery by integrating structural, lexical, and semantic information. And also, there was work in LLM, that is large language models, that enables automatic mapping of code entities into architectural components. But they both are very powerful. While they both are very powerful advancement, but these modules also lack. In some interpretability decisions, and these models were acting as black boxes and does not provide any explanation of their decisions. So, looking at the current state of research, most AI based methods either focus on general purpose software systems or just provide greater accuracy. However, embedded systems which operate in safety critical environments where understanding is essential, the developers need not only to accurate results but also clear explanations of how and why architectural decisions are made. So the problem statement is this work proposes an augmented approach to automatically recover high-level architectural diagrams from embedded source code supported by interpretable explanations. Moving on to the methodology, you can see diagram on my screen that shows what methodology I have followed. So I started with collecting the dataset from GitHub. We had a number of repositories in which there was an embedded code written in C++ and Arduino code. So I targeted mostly the C++ code, which contains only one file. So just as a MVP for this, then we preprocessed and built the graph cement and followed by semantic representation. Then I trained a lightweight GCN based dependency prediction model, trained it and evaluated on different matrices. And I added explainable AI using the GNN explainer and generated high level architectural diagrams. So, moving deep down to the methodology, first step was the pre-processing and graph construction. First, in the pre-processing, we, as I have told you before, that I have I collected the dataset from GitHub that consisted of the embedded system code in C++. So the code mainly has a main function and a number of different functions. So based on the source code for function, the source code was used to extract function calls file level dependencies, and from that we build functional level call graphs and also assign initial components categories such as utility, input output, communication and computation to all the functions regarding their names. Next, we use codebird to extract embeddings for each function. These embeddings capture important semantic information based on what function names were. So this was all the pre-processing phase and the semantic representation. Then we trained a graph neural network and we use GCN for this. And the GNN model operates on component level graph and predict interactions between the components and classifies it into categories like utility, communication, computation, interfaces, etc. So this learns latent architectural patterns and mapping low level function interaction, high level modules. So once this is done, we move to the GNN explainer, which shows the subgraphs, nodes, edges, etc., and tells the confidence score of each of the decision that the GNN has made. Also at the end, which is the most proper solution of our problem, the high level architectural diagram, it represents the visual representation of the components and in their interactions, and also it shows the even the graph shows the main components of the code and also where the handlings is being done. So, moving on to the results, as you can see, the graph neural network which I used performed very well with the accuracy of 91.87 and precision of 96.48. In the next slide, I'll be also showing the graph which it made. So, there was a source code which had different functions, and based on these functions it predicts a graph which had utility, data storage, error logging, hardware, IO and interfaces. So also it shows a deep linkage between the components, and also it has XAI summary in which the AI presented the confidence score of why it predicted the graphs and what are the like decisions they made. So in the future work, as I have told you that I have only connected with the GitHub source code, which has only one file containing the main function and other functions, other utility functions. So the scalability can be improved by extending the pipeline to large multi-module embedded projects, and we can have optimized GNN and graph processing for larger code bases. Also, we can enhance explainability beyond the GNN explainer and to provide a richer insight in why components are grouped and why the edges are critical. And also in this work, I have only catered on C++ language function. So in the future work, we can have different programming languages beyond C and C++. So this was all from my side. I'm open to questions if you have any.
Reena
Okay,
ma'am, any
nice
questions?
presentation. Yes. I'm asking the question. Nice presentation, Ardaks. And
Thank you.
I'm happy that you are exploring this topic very well. Could you please go to the first slide?
First slide.
Yes. Okay. Okay. So my question is, how many papers you have referred to identify the research gap?
And so in my research paper, I have written almost 17 papers, but I have read almost 20-25 papers for that. And I've only like catered 17 to 18 papers in my research paper.
Okay.
So
So
also the
accordingly,
literature review that I have catered consisted of different technologies, starting from the tool-based and the mainly solution, and then we move forward to the AI based solutions. So I cater the AI
mhm.
one then.
So what challenges do you face in interpretation of low-level embedded code into the higher level?
In the mainly there were, as I've told you in the literature review.
Mhm.
Sorry.
Yes, please go ahead.
Yeah, in the literature review that I have told that I have catered different papers. So from the starting, we had the tool based interpretation, and we have different tools, but these were having only static analysis, and these lack also the uh, explainability skills of why the high low level language is converted into high level language, and what are the decisions behind it. So my research contributes not only to convert the low level code into a high level architectural diagram, but also it's have some explainability skills as well, which I am exploring to enhance further in the other works as well.
Okay. So when we go with generating this high-level architecture manually, okay, so we will find some gaps. Fine. So how
Exactly.
much percent accuracy it will be giving? How much percent of accuracy your automated generation work? Okay, what you have suggested. So I would like to know accuracy. How much accurate it will give you?
And so in the results, I have shown you that the accuracy was my architectural diagram had was 91%. So also
Okay.
we had some limitations here, because as I've told you, I have only targeted the only targeted the source code, which had only one file having a number of function components. Like we had the main file,
Mhm.
main function, and then we have a different number of functions in the main file, that's the which the main is calling. So we had some limitations with the data set, but still it performed really well.
Okay. Okay. Thank you very much.
Thank you.
Yeah.
Yes, I would like to welcome Prashant Suryavanshi, who has joined us as a session chair. Prashant sir, before I do your formal introduction, do you have any questions for Agdas ma'am? All right, thank you, ma'am, for your presentation.
Thank you.
So we have with us Dr. Prashant Suryavanshi. Dr. Prashant is the principal of Honorable Shri Babanrao Pachpute Vichardharas Trust, Parikrama Polytechnic, Kashti, Maharashtra. His research interests include software engineering, computer systems, and computational processes, along with network architecture and network security. He actively contributes to academic leadership, teaching, and institutional development in technical education. A warm welcome to you, sir, and please share an introductory remark for the presenters. All right, let us move on to the presentations. Now, next, I would like to call Amit to present a study on development and strategic analysis of a Java based healthcare management system with integrated web RTC telemedicine, bridging the digital divide in emerging markets.
Mm, Hi, ma'am. Yes, ma'am. Uh, Can I share it?
Yes, sir.
Yes.
Yeah, 1 second.
And one more request from my end. I would like to request all the participants while presenting presentation, please keep your video on. Bye, ma'am. Can you
Yes, ma'am.
please announce next presenter so that that presenter will be ready? है ना?
Yes, sure, ma'am.
Next two
Amit sir,
presentations.
please. Yes, ma'am. Amit sir,
हाँ.
please try to resolve your technical issues. I will call the next presenter by then. Mohammed Sakleen. Mohammed sir, are you present?
Yes, ma'am. I am present.
Yes, sir. Please present your paper on hyper-GNNs for multimodal classification and severity analysis of neurodegenerative disorders.
Yeah, sure. Yeah, can you see my screen?
Yes, sir.
Yeah, sure. Yeah. So, a very good morning to everyone. I'm Mohammed Saklain. I'm presenting on behalf of my team, consisting of uh, K. Bhavesh Raju, Musadik Pasha, and Nishan Padantaya, along with our guide, Dr. Jayshriyar, with the topic hypergenans for multimodal classification and severity analysis of neurodegenerative disorders. So the problem statement which we are trying to address over here is, as we know that Alzheimer's disease is a progressive neurodegenerative disorder, and there are like very common symptoms related to Alzheimer's disease, MCI, and other similar neurodegenerative disorders. And there is a very high chance that the misdiagnosis rates can go up to 15 to 20% as well. So current AI approaches are limited by poor multimodal integration, lack of interpatient relationship, and also may sometimes not consider genetic factors as well. And hence, we try to assess severity by capturing complex relationship between patients, ultimately supporting the decision making. So moving on to our methodology, we initially start off with pre-processing and feature extraction, where raw MRI scans are processed to extract relevant features. Then we extract imaging features. The extracted imaging features are merged with the tabular patient data, including the demographic information and the genetic information as well. Next, we go ahead with our model, which is basically a hypergraph. The combined data set is used to construct a feature-centric hypergraph, and then which is then fed into our neural network for disease stage classification. And then we go ahead with severity modeling, where we have an unsupervised learning mechanism where we classify the disease into a specific severity. Post that, as we know that explainability is very important when it comes to healthcare, we have also integrated explainable AI over here, where we get to know which feature is contributing the most to a certain decision. So moving on to our modules and implementation, we have used PyTorch and PyTorch Geometric for graph machine learning, scikit-learn for unsupervised learning, basically, and SHAP for explainable AI. For the backend, we have utilized Fast API to build RESTful APIs. For frontend, we have used Next.js, which is basically a React framework. For training and compute platforms, we have used Kaggle, and the backend and the frontend currently runs on our local server. So moving on to our processing workflow, we have the MRI brain scan, which is basically DICOM files. Then we go ahead with the normalization, and then we do the brain extraction basically, and then we go ahead with the feature extraction. The brain extraction part over here is then used for clustering, which is basically our severity modeling, and then we go ahead with the tissue segmentation, which basically helps in explainable AI. Post feature extraction, we do a visualization of the 3D brain segmentation, and then we extract all the features in a comma separated format, which is then used into fed into our hypergraph model for classification. Post then we get the results and insights. We classify into Alzheimer's disease, MCI, or CN, and then we do severity modeling here. Basically, after our feature extraction, we get the results over here where we can see the original image, the cerebrospinal fluid, the gray matter, and the white matter. And then all these, helps us in explainable AI as well. And it also helps in extracting features for uh, our disease classification. How we are constructing our hypergraph. So the all the feature engineered features are both volumetric and statistical is treated as a single node in the graph. Hyperedges are constructed based on patient similarity. Uh, and this is how basically we construct our hypergraph. And then while training, we have like three consecutive convolutional layers of hypergraphs. They perform information aggregation through hyperedges, and then we pass it on with the relu activation function to introduce nonlinearity and a dropout layer to prevent overfitting. The final layer is a multi-layer perceptron classifier that classifies into different categories for our final class predictions. And then we go ahead with the severity modeling, where we have an unsupervised learning approach where we use k-means clustering along with k equals 3 as the parameter to classify into three categories. Coming to explainable AI, we utilize SHAP Deep Explainer, calculate SHAP values to quantify the contribution of each input feature, and then explaining random forest severity model. Uh, we use sharp.tree explainer. This is basically like something which relates to our baseline model. Okay, coming to our results and conclusions. Training and evaluation, we achieved a test accuracy of about 95%. We applied k-means clustering to create three labels, and then we trained a random forest classifier to predict these cluster labels again, and then we almost achieved perfect results. For transparency and clinical interpretability, we used SHAP analysis because for healthcare professionals, it's important to show how we are classifying things rather than just to show it as a black box. So this is how our your user interface looks like when a healthcare professional enters all the patient information along with MRI scans. Yeah, so we obtained a very robust overall performance and results with about a 95% accuracy even after cross validation and adding noise perturbations while testing. This shows that there is reliable generalization and there is not too much overfitting. So HyperGNN framework offers several clinical advantages, including accessibility as it requires only structural MRI and clinical data. It supports early detection and can also help in early intervention. Explainable predictions build clinical trust and enable verification for reasoning as well. Yeah, that was it from my side. Thanks. We are open to questions.
Okay.
Ma'am, any
Nice
questions?
presentation.
Yes,
Yes,
yes.
yes. Yeah. Nice presentation. And you have traced the problem, which is severe,
Right.
actually, and it has, yes, and it has to be addressed. So I'm very much thankful that you have selected such a nice topic for your research. So here I would like to ask one question. How your model are best in supporting uh, clinicians or doctors in diagnosis of early diagnosis and treatment planning for this kind of diseases, critical diseases.
Okay. So we don't uh, we don't model a certain plan for diagnosis, but we can help in early diagnosis. So as we know that there are like three stages of Alzheimer's, which is basically first it starts off with a normal, cognitive normal, and then it comes mild cognitive impairment, and then we go ahead with Alzheimer's disease. So when once the healthcare professional enters all the information along with the MRI scans, we give you a certain decision, let's say if it's cognitive normal, and then we give you a severity model as to how severe it is. Let's say it's cognitive normal, and let's say it's very high severe, which means the patient is slowly moving towards mild cognitive impairment, and so on. The thing, it basically progresses based on our severity model.
Nice. Thank you very much.
Yeah, thanks.
Prashant sir, any questions for him? All right, thank you, sir, for your presentation.
Thanks.
Amit sir, are you able to share your PPT now?
Yes, ma'am.
All right, Amit sir, please present your paper on development and strategic analysis of a Java-based healthcare management system.
One second, I can.
And next, we will be having Zhao Zhu. Zhao sir, you are next after Amit.
It is visible, ma'am.
We can see your Zoom screen, sir, not your presentation.
Ma'am, 1 second.
फिर मान चुजा चार बांसुरी का करते गया
It is visible, ma'am. My research paper visible?
No,
Give
no,
us a
no.
moment, sir.
No, it's not visible.
No, sir. We can see a black screen, not a PPT.
1 second, ma'am. I can try again.
Sir, please try one last time, or else I will request you to please share your presentation recording to us. No, sir, we still cannot see. After this, please make a video of a presentation and please share it to the team.
Okay, ma'am.
Yes, sir. Thank you. Now, next, I would call Zhao Zhu. Zhao, sir, are you present here? For the paper Research Status and Challenges of Electronic Waste Small Component Detection based on Improved YOLO V8. Or any of the co-authors? All right. Sangam Kumari. Sangam Kumari or any of the co-authors?
Yeah, hello. Yeah,
Yes, ma'am. Please present your paper on Smart Expenses Tracker, Manage Expense Smartly.
yeah, just a second. Yeah, right.
Yes, after Sangam, Vedant. Your
Hello.
presentation is next, sir. Yes, please continue, ma'am.
Ma'am, is my screen visible to you?
Yes, ma'am.
Yeah.
Yes, ma'am, your screen is visible. Please start with the presentation.
Yeah. Yeah, so good morning, everyone. We are with the team, and we are from Our College of Engineering and IT from Jaipur, India. And our today's presentation is from Smart Expense Tracker. So basically, Smart Expense Tracker is a system that helps users to manage their daily expenses in a smart and automatic way. And just a second, let me show you this. Yeah. And instead of writing expenses manually, the system records, categorizes, and analyzes the expenses automatically. It also shows the spending patterns, also the charts, the dashboards, so users can understand where their money is going and improve their financial planning. Here are the key features of our technology. So basically, the OCR is the optical character recognition. It is used to scan, decrypt, and extract text from the images when the user uploads. Instead of manually typing the expense details, the users can simply upload the receipt and the system will automatically detect the amount, date, and other details, whatever they needed.
Madam,
So
excuse
let's
me.
come to the
Could you, eh,
yeah.
ma'am, could you please switch your presentation on presentation mode first?
Okay, just a second.
And could you please on your video?
Yeah.
I request all the participants to please follow this instruction.
And is it visible to you?
Not, yeah, now it's okay.
Yeah. So let's come to the technology we have used here. So Java is the main language we have used, and as a frameworks we have used the Spring Boot as a backend, and for the development part we use the Java efforts, which is used for our user interface. We have also used MySQL to store our data, basically for the database, and we have used our machine learning to for the smart categorization, and yeah. Our next is OCR, which I told earlier. It's for our receipt. Basically, it scans our receipt, and next is our cloud, which is used for our storage and scalability.
Ma'am, I can't see your slides properly.
Okay, just a second.
Text are not readable properly. I think it's zoomed.
What am I visible to you?
Yes, it is visible, but it is something like blurred.
Just give me a second. Is my presentation visible to you?
Yeah, is okay. Please proceed. Yeah.
Okay. So basically, what we are doing in this our project is that the project is solving that our project solves several problems. The manual expenses tracking in time, which consumes very much time. People forgot where to spend their money, where to their proper budget of their money. So this project, in our system, it provides automation, real-time tracking, and insights, which helps users to manage their money in the better way. Let's come to security. So here, since the financial data is sensitive, security is very important. So we use the login system, encrypted data storage, and protected database access to ensure the user's data should be private and safe. And next is our result. So our system gives a very good result. We have already used it, and currently it is giving us 85 to 90% of full accuracy. We have a very fast performance, and it and we have also the charts and dashboards which it generates very quickly. Users find it very easy to use, and we have practically used our app. So let's come to the conclusion. And in conclusion, the smart expense tracker It's a simple and intelligent solution for managing personal finances. It reduces manual work, improves financial awareness, and helps the users to make a better financial decision. It is also scalable, it is secure, and it is very easy to use. So yeah, thank you, ma'am.
Any questions, ma'am? Ma'am, you are on mute.
Okay, nice presentation. Here my question is, what intelligent feature differentiates your expense tracker from existing applications?
And the best part is that we have used, first of all, the technologies we have used. That is our best part. Because Java is already we know that it is a platform independent language. And we use Spring Boot. Spring Boot is very scalable for the backend. MySQL we have used just because it is very best for if we have to store any data or it is very efficient data storage part. And when we come to the machine learning, it is very intelligent categorization. So our technology was, I think, the best part we have used here in our project.
Okay, here what type of expenses you are referring? As your paper title is Smart
So,
Expenses Tracker.
yeah. So basically,
So,
this project involves our personal expense tracker, just like a daily use. We expense our just like for example, my salary comes and I don't know where to use. Like I have to pay my rent. I have to pay my bills. Okay, there are too many things.
mm-hmm,
We have some our miscellaneous expense also. Basically, this
mm-hmm,
project is just for our personal use that we can track our expenses by our own
mm-hmm.
self, that where and how to do.
Yes, agreed.
What, ma'am? Can you please repeat?
Yes, what you are explaining, I agreed about it. Okay, so you are referring that expenses about expenses is something like how we are financially managing the things, day-to-day things. Okay, so how does the
Yeah.
system provides personalized financial insights to the user?
Yeah, basically, we give a personalized dashboard to a user. When they log into
Mm-hmm,
the dashboard, they get a perfect UI where it gives an we basically we are using that API to connecting the bank also. And hello, am I audible?
yes, yes, please go ahead.
Yeah. So basically, we have used this as because we have made a personalized UI for an user where they can
Mm-hmm,
log in there and they can put in their expenses like they can categorize themselves and they can if they want to pay their bills so they can categorize that if they can there is also a feature that they can add their expenses. It is also connected to the bank also so they can get the proper they can get proper scope. Yeah.
okay, so you said that you have used Java. Okay,
Yeah.
why not Python?
Yeah, ma'am, just because personally if you say then I felt that Java is very advanced language and it was very first of all it was very connected to me also because I felt that easy to make. That was a personal reason. But yeah, Java is very independent language and very high level language. So I think Java is best for when we have to do this crucial projects making. So I think this is the best. So,
Okay, as you are comfortable with Java, that's why you have selected Java.
yeah.
Okay, but my point is, Python has more libraries, it has more functions as compared to Java. Okay, so whatever stuffs you have done using Java, you can try to do it parallelly using Python as well. Okay, So rest is
Python
okay.
is, of course, Python is good. Yeah, Python is good, but it is basically it is too much good for machine learning. But Java is better for
Yes,
building
yes,
a complete and scalable application. So we use
yes.
Java.
Okay, okay. Thank you very much.
And yeah, thank
Mm-hmm.
you so much.
Yes, thank you, ma'am. The next, I would call Vedant Khade to present his study on the development and effect of AI-powered farmer support chatbots. Vedant, sir?
Yes, ma'am.
Yes, sir. And after this, Aditya Kasture will be presenting. Vedant, sir, please start with the presentation.
See my presentation.
No, sir, we can see your Zoom screen.
Dhimahi,
Yes, ma'am.
I can see Dr. Prashant Suryavanshi sir is there in the meeting. Uh, just a few minutes back, I have seen that he kept his video on. So could you please call him if he is available for the introduction?
Yes, ma'am.
So
Prashant,
at that
sir?
time.
Yes, sir. Am I audible to you, Prashant, sir? Hello, sir, you are not audible.
Yes.
Hello, good morning, sir.
Sir, I guess you are on mute. Some network issue might be there.
Ma'am, we'll try to resolve that with
Yeah,
Prashant, sir. Till
yeah, yeah,
then,
yeah. Okay.
yes.
Yeah. We'll continue with Vedant.
Yes. Vedant, sir, please start with the presentation. Are you sharing your screen, sir?
See my presentation.
No, sir, your screen is not visible yet. Ma'am, are you able to see his screen?
No.
All right, Vedant, sir, I will call the next presenter till then. Please check your network settings or any technical issues you might be having.
Okay, ma'am.
Aditya Kasture, sir, are you present?
Yes, ma'am.
Yes, sir. Please start with a presentation on the next generation of code quality assurance, AI accelerated code review platforms.
Yes. Ma'am, it is visible.
Yeah.
Yes, sir.
So, good morning, everyone. My name is Aditya Kasturi from the Tamil Institute of Higher Education and Research, Wardha. Today, I present my research paper on next generation of code quality assurance AI accelerated code review platform.
Aditya,
Authors.
switch your presentation. Please switch your presentation on presentation mode.
Yes, ma'am.
And keep your video on. Please keep your video on. Yeah.
Visible.
Yes, yes. Please proceed.
These are the points are including in my presentation. First, we go to introduction. AI is rapidly changing the software development and maintain the modern industries. It helps developer work faster and deliver products quickly, but it also increase the code complexity. Traditionally, manual code review is slow, depend on human efforts, cannot handle large-scale modern system. Therefore, we need to use smart AI code-based system that improve code quality and accuracy and software development. AI-based system can analyze code faster, provide real-time feedback to developers. This system helps detect bugs, security issues, performance, and problem more effectively. AI-based review system is help developer by providing faster and more accurate feedback during the development process. Move to methodology. First part is research design. The study uses qualitative, analytical, and comparative research designed to evaluate AI-assisted code review system. This is mainly focused on understanding how AI improves code quality and assure accuracy, bugs and vulnerability detection, review speed and efficiency, automated feedback generations, emphasize evaluation of ML and LLMs, machine learning and large language models, and real-world implementations. The second part is literature review. The study of recent research papers. Research papers, AI-based code review systems, and their impact on software development. This mainly focused on AI ML in code analysis, role of LLMs in detect bugs and issues, comparisons of manual and automated review system, limitations or challenges existing approach, emphasize to understanding current trends and research gaps. These are some research paper I preferred in my research paper to write my paper. First is code agent and autonomous computative agent for code, and second is code review automations via multi-task feedback LLMs. Third is AI-based software vulnerability detection, and fourth is intelligent AI-driven automated code review in agile development, smart scan, AI-powered code analysis and review. These are the papers. And third part is system design. The proposed system is designed to automate the code review focused process using the advanced AI technique focused on parsing and pre-processing. These are some statistic tools I used in my project: textile, PMD, and spot bugs, AI-based review models, feedback generation and display, emphasize integration of AI with traditional code analysis and methods. The fourth one is evaluation criteria. The system evaluated based on its performance, effectiveness, real-world scenarios, mainly focused on accuracy and bug detection, reduce code review time, quality and clarity for the feedback, scalable and system efficiency, emphasize improvement in overall software quality. The fourth one is data and tool use. The study uses various datasets to use and analyze to improve code review process, focused on use of real-world code dataset like GitHub repository, statics tool, analysis frameworks, ML and LLMs, integration with development tools, and continuous development pipelines, emphasize practical implementation in real-time uses. The move to objective to develop an AI-based code review platform for modern software development, to use of ML and LLMs for intelligent analysis to detect bugs and security, vulnerability, and performance automatically, to reduce code review time and improvement the speed of development, to provide and clear feedbacks and suggestions to the developer, to improve overall software quality and reliability. Go to flowchart. The system receives the code from the user, carefully processed by the converting into structure formatting. For better understanding the process, code is analyzed using both basic tools and advanced AI models to detect error, bugs, and security issues and performance problems. The system then generates clear and detailed feedback and useful suggestions which are displayed to user to improve the code quality. Result and discussion. The system is reduced code review time by 60-70, making development faster. It improved bug detection and fast security performance issues and more accurately developers receive quick feedback which help to improving code quality. This system can handle large complex code base easily. However, sometimes give AI give incorrect solutions. There are challenges like data privacy, lack of full transparency. So we human supervision is still important for the AI for the correct decisions. And these are the some references I used in my paper. Thank you.
Nice
Ma'am, any
presentation,
questions?
Aditya. Yes. Nice presentation, Aditya.
Thank you.
Here I would like to ask, what challenges arise in detecting logical errors?
I used ma'am, I used AI MLs, matlab artificial intelligence and large language models for the better accuracy and give the better code for the user.
Okay, so how much percentage of accuracy did you achieve here with this work?
Ma'am, in my projects, it gives 70 to 80% accuracy for the users.
70 to 80%?
Yes, ma'am, I definitely improve the code quality in future.
Mm-hmm. Okay, so that is what my suggestion, because the 70 to 80% increase in the accuracy doesn't mean like it is, ideal accuracy. So try to use such algorithms and models that will give you or that will enhance accuracy at least up to 90%, 85 to 90%. Okay.
Yes, ma'am.
Okay, so that's it from my end, ma'am. Hi, ma'am. We can go with the next presentation. Thank you,
Yes.
Aditya. So, yeah.
Thank you.
Yeah.
The next I would call Shrujana Patil to present her study on urban scene intelligence, a semantic anchor and expand framework for grounded scene understanding. Shrujana Patil or any of the co-authors? I repeat, Shrujana Patil or any of the co-authors of this paper. All right, Amit, can you try one last time to share your screen for the PPT?
Hello, hello. Yes,
Yes,
ma'am.
sir.
1 second, ma'am. It is visible, ma'am.
Yeah.
Yes, sir, we can see your PPT.
Good morning to everyone. Here I am presentation on the topic development and strategic analysis of a Java-based healthcare management system. And 1 second, ma'am. 1 second. Now the topic are introduction, technology used, about the topic, key features of technology, system, architecture and design, real-time problem statement and solution, implement details, healthcare system, why this technology is used, authentication of technology, result and analysis, comparative study and conclusion and references. Here, here my project introduction is traditional healthcare delivery faces scalability and accessibility challenges. COVID-19 accelerated telemedicine adoption and normalized remote health delivery. Uh, India's doctor to patient ratio is suboptimal. Rural populations face major geographic barriers. Digital infrastructure is growing rapidly, but the digital divide remains a potential barrier. And objective is develop a unified Java-based healthcare management system which integrated WebRTC telemedicine. Here we use technology are Java SE, Java Swing, JDBC means Java Database Connectivity, MySQL, WebRTC, JITSI Meet, and three-tier architecture and prototyping module. About my topic is Java-based desktop healthcare management system with telemedicine integrates clinical workflows with administrative system and secure role-based access control for patients and doctors and appointment scheduling with real-time database. WebRTC-based video con consultation via JTC Meets integration, designed for Tier 2 and Tier 3 cities with legacy human support, and bridges the gap between patients and providers through technology. And here key feature of the technologies: Java and Swing platform independent write once run anywhere capability, MVC based UI with stable desktop performance, automatic garbage collection for long running application, and MySQL and JDBC relational integrity via foreign keys for patients and appointments, database agnostic API, easy to switch between RDBMS system, normalized to 3NF to minimize redundancy. WebRTC and JITSI meet real-time encrypted video consolidation via browser, unique time-stamped meeting URL for every appointment, offloads video processing to browser, keep Java app lightweight. And system architecture and design used. We used here architecture 3 tiers. The first tier, presentation tier, and the second tier, application logic tier, and the third tier, in which we use MySQL database with JDBC driver. And key design patterns, role-based access control, RBSC for patients and doctor roles, card layout for smooth panel, and a prepaid statement to prevent SQL injection attacks. Here we use database design also normalized to 3NF, two core tables, users and appointments linked via foreign keys, unique uh, timestamped JTSI meet URL stored per appointment. And my real-time progress statement and solution. Here, progress statement are high cost barriers, infrastructure dependency on high bandwidth, internet in rural areas, fragmented system for looking and video consolidation, data privacy risk using unsecured platform like WhatsApp या फिर Zoom. And the solution is lightweight Java desktop app runs efficiently on legacy hardware, offline capable UI, unified platform integrating scheduling and telemedicine in one system. Encrypted JTSI meet URL ensure secure private consolations. And here implementation details healthcare system. Core modules includes user authentication via prepaid statement, role-based dashboard, separate views for patients and doctors, card layout navigation for smooth panel transitions, dynamic SQL queries based on user role, patients or doctor, platform feature JTable with mouse listener for double-click appointment joining, desktop get desktop browse, launch a browser for video call, and here we describe why this technology is used. Java SE for the region selection, platform independence via JVM runs on Windows, Linux, Mac OS also, and Java Swing stable desktop UI with low RAM usage, and JDBC database agnostic API, MySQL relational integrated with foreign keys for structured healthcare data, and WebRTC 3 open source encrypted real-time video, and a prototyping model iterative development with stakeholder feedback at which stage, and authentication and security features here are prepaid statement prevents SQL injection attacks, J password field mask password input on login screen, role-based access control, unique encrypted JITSI, meet URL per appointment, local database hosting ensures full data sovereignty, and ensure sensitive patient data protected from unauthorized access, control role specified dashboard views, safe and private medical consultation management. And here is result and analysis we described. First of step, all tests passed, then login and authentication, then appointment booking,
Excuse me,
then
sir.
again,
Gentle reminder that you've crossed 9 minutes. Please conclude your presentation now.
and here we describe results, and here we used comparative study about this project, and here we have conclusions list, and also these are references. Thank you.
Okay. Nice presentation.
Thank you, ma'am.
So here, actually, I would like to give you suggestion.
Yes, ma'am, sure.
Whenever you are presenting your presentation in such a wide platform, so I think you have to, you know, read your presentation content twice at least, because I can see most of the terms. I think you are reading for the first time. For the objective slide also, you have added in the introduction slide itself. Okay. There is a potent you have written in one of the slide and you are reading it as a potential. Okay. So
Mhm.
this is just suggestion. Okay. Otherwise, whatever work you have presented, it is good. So according to your title, which represents development and strategic analysis of Java-based healthcare management system with integrated web RTC telemedicine. Okay. So,
Okay.
yeah, I would like to know what is the specification or feature of web RTC? What this web RTC do?
Ma'am, WebRTC is an open standard technology used for real-time communication directly in the browser without any external plugin. And here features
Okay.
like real-time audio, video communication, end-to-end encryption for
Mm-hmm.
secure communication, and many
Mm-hmm.
more.
Okay.
And one
So
also
as you
peer-to-peer communication.
Okay, very good. So, as your project is related to healthcare management system, my question
Mm.
is, what security measures are implemented to protect patient data?
Can you repeat, ma'am?
Yeah, what security measures you have implemented in your project to protect patient data?
Yes, ma'am.
How you are
We
protecting patient data? Yeah.
Yeah, ma'am. Ma'am, we implemented multiple security measure here. First, we used prepaid statement in JDBC to prevent SQL injection attacks like. And second is we implemented role-based access control, so only authorized user, doctor or patient can access specific data. And the third is password are secured using J password field, which makes your input during login. And also we used each telemedicine session uses a unique encrypted JITSI meet URL ensures secure communication.
Okay. So that's it from my end. Over to Dr. Prashant, sir. Dr. Prashant, sir, can you hear me? Would you like to ask any question, please? Dr. Prashant, sir.
I think he's having some audio related issues.
Okay. Yeah, no problem. Please go ahead, ma'am.
Thank you so much, ma'am.
Yeah.
Yes, thank you. Now, Vedant Khade, can you please try one last time to share your PPT screen?
Yes, ma'am.
Sir, are you able to share?
Yes, ma'am.
Sir, can you please let me know what difficulty are you facing right now? Hello, Vedant sir, am I audible to you? Vedant Khade, what issue are you facing?
Ma'am, PPT is not visible.
Then I would
Menu bar,
request you
please.
to please have a recording of your presentation and share it to the team. We will consider that.
Hello. Huh.
All right, we'll move on. Now, this is a last call for Maureen Bamania. Maureen Bamania or any of the co-authors of this paper. Zhao Zhu, Shrujana Patil.
Yes, hello. Can
Yes,
I
ma'am.
start presenting?
Yes, ma'am. Please present your study on urban scene intelligence, a semantic anchor and expand framework for grounded scene understanding.
Yes, thank you so much. I'll share my screen. Is my screen visible?
Yes, ma'am.
Yes. 1 second, please. Okay. So, good afternoon, respected panelists. I'm Shrujana Patil, and I'm here to present my work titled Urban Scene Intelligence, a semantic anchor and expand framework for grounded scene understanding. So this work was done in collaboration with my teammates under the guidance of Professor V.R. Badri Prasad. So moving on. 1 second. Yeah. So moving on to the introduction. Imagine you're looking at a busy city street. What do you see? You see cars, pedestrians, traffic lights, storefronts. But traditional models, when asked to detect or understand the scene, they only end up detecting objects. They don't truly understand the scene. This is because urban environments are inherently complex. They demand a lot more than just object detection. You need to be able to understand the relationships, the context, and the real time dynamics. All this becomes all the more important when you have to do traffic management, smart city planning, emergency responses. So you really have to understand your urban environment. So we do have end-to-end approaches that are already present, but they mostly act like a black box. There is no transparency, there is no error isolation. So everyone today is obsessed with training multi-billion parameter models. There are bigger models, more data, but nobody is talking about building better systems with more reasoning, right? So, what we have tried to do differently here is using an end to end approach, which does not duplicate the capacities. They already use well established models exactly and precisely where needed. So, our method enhances existing architectures through a structured integration. All the models that are present in the market right now are siloed, which means there is no interoperability. Each model excels at one task, which means there is no coherent pipeline that exists. Research focuses on bigger models, not better systems. So, reusing specialized components allows for improved efficiency and modularity. With that, I would like to talk about our framework. We'd like to call it the Semantic Abstract and Expand Framework. It is a modular and a resource efficient approach to generating grounded image descriptions. So, this framework is divided into three components: visual extractor, semantic graph generator, and narrative synthesizer. The visual extractor is used to identify objects, its attributes, the context of the scene. The semantic graph constructor is then used to take the input from the visual extractor and build a structured, interpretable fact or scene graph. And the narrative synthesizer is then used to convert all this information into a description, into a clean, structured, and a polished paragraph. So, all this is to analyze an image like a human being does. So, this is the scope of our problem statement. I will explain all of this in greater depth moving ahead. So, moving on to Module A, we would like to call it the Advanced Perception Model. Here, Module A begins with understanding the overall vibe of the scene. It understands how is the lighting, the shadows, what is the tone of the weather, and gives one particular word. Is it sunny? Is it cloudy? Is it rainy? Things like that. Then we move on to the structural foundations of the scene. The first part is object detection. Object detection is done by OWL-VIT, which is an open vocabulary vision transformer. This is used to identify people, traffic signs, storefronts, vehicles, and generate bounding boxes with a certain level of confidence. Then we move on to semantic segmentation. Semantic segmentation was added for the context of urban environments. So we map regions, we map regions like road, there's the sky, there's the building. So semantic segmentation is used to segment your images into multiple parts. Then we have depth estimation. Depth estimation is used for spatial awareness. We understand from a depth map how close or how far is a particular object from the eye of the human being. So depth anything is used to classify every object into foreground, midground, or background. An additional thing that we've done is we've used DB scan to detect crowd clusters. Let's say there are a bunch of 3 people that is tagged as a group. So this allows us to have a lot more detail into understanding a specific scene. So the final output from module A is a JSON file which has a complete human level structured representation for downstream tasks. So this is the output from module A. Like you can see on the screen, there is object detection happening. And this is the output from DB scan, where you have a taxi stand, a bunch of pedestrians are grouped together. And this is the output from segformer, which is the semantic segmentation map that we've obtained. Moving on to module B. Module B receives the output from module A, but what it does is it cleans and standardizes the data. It ensures that the bounding boxes, spatial regions, the confidence scores, all of them are valid and consistent. I'll tell you why this is important. Let's just say you have a relationship which says car on a building. You cannot have a car on a building, right? So these logical inconsistencies are corrected and they are eventually placed in a better region of the scene graph. So they're not just detected, but they're also corrected at this stage. So the final output here is a clean, structured scene graph that is ready for downstream reasoning. Every object lands in the right zone before any sort of reasoning begins. The last module is our advanced narrator. We are using Quen 2.5 3 billion model here. Something that we've tried to do a little differently here is we've used 5 different styles of narration. Each narration style caters to a different set of audience. So if I'm somebody who wants to quickly understand the scene without getting into the nitty-gritties, I would go for a more concise and a more quick understanding of the scene. Whereas a blind person detailed paragraph will require going down to the smallest detail possible, right? Because you want to explain it to them like you are explaining to another human being. So the output here is human readable, clean, structured, and polished paragraph. Moving on to the results. So this image on the left side was what was given to our system, to our pipeline, and the paragraph is what you can see on the right hand side. There are a few things that I'd like to highlight from this paragraph. So it says diffuse cloudy daylight. If you can see, there is no visible sunlight on the in the picture towards the left. So it is slightly cloudy or rainy, as you can call it. And it also talks about a large cream colored bus that is near the curb, a small gray sedan approaching along the curved road, a group of pedestrians, which we're not really sure, are they prepared to board or unload from the bus? There are no stores. There are no visible stores here. There are no tall buildings that are visible. There is a soft canopy along the roadway. So these are all important points. So when you read this paragraph, you should be able to reconstruct this particular picture in your mind. And if we're able to do so, I think we come very close to what a human being would explain things like. So we've evaluated our model against the blip model, and we've evaluated it for 4 standard captioning metrics: the blue score, the meteor, cider, and spice. So these are the metrics that are visible to you. These are what we've achieved. So a good blue score over blip signifies that we do have good lexical accuracy. But the stronger metrics here are cider and spice, are cider, meteor, and spice. So meteor is more for semantic similarity, right? I need to make sense when I speak, and that is what meteor measures. Cider is for a human-like caption agreement. So there has to be a little more intelligence involved when you're talking about something, when you're describing something like a human being. So, and spice is used for the scene graph. How well was the graph constructed? So these are our metrics, and we do notice that we are doing moderately well over blip in the blue segment, but compared to the other non-state of the art models, these are our metrics. So compared to typical benchmarks, our metrics are consistently higher, especially in terms of semantic fidelity and scene graph correctness.
Excuse me, ma'am. You've
Yes.
crossed your. Acha, okay.
Yeah, I'm done.
Yeah, nice presentation, Dr. Srijana.
Yeah, thank you so much,
And
ma'am.
yeah, and you have wonderfully presented it.
Thank you, ma'am.
So, yeah. So, as per the topic you have selected, here I would like to ask one question that in the urban areas, we can see such a constructions, where there is hardly gap we used to find. You know? So, how does your approach handle such a dynamic and complex urban environment?
Ma'am, firstly, like I already explained, it is because it's very complex, you try to understand it like a human being. How do we teach children? They first understand that this is a building, this is a road. So object detection does that. And then in the module B is where the real intelligence lies. So we connect everything together. So we have a structure where everything that is detected, a car is detected, a building is detected, but the car has to be on the road. So we have 2 nodes. Car and the road are 2 nodes, and there's a relationship between these 2 nodes. So car is on the road, car on road, girl holding an umbrella. So each of these relationships are mapped out. All of this is present in the scene graph. So when it's present in the scene graph, that particular scene graph has all the amount of, it has captured all the complexities of the image. And that in turn is given to the narrator. So the narrator, it takes all this information and converts it into a natural language, like how a human being understands it. Yes, ma'am.
Okay, thank you.
Thank you, ma'am.
Yeah.
Yes, thank you, ma'am, for your presentation.
Thank you so much.
Now, Maureen Bamania. Sir, are you present now?
Yes, sir. Yes, ma'am.
Yes, sir. Please present your paper on a review on framework for detection and prevention of email phishing attacks.
Yes, ma'am. Uh, Hello everyone, my name is Maureen Bamania. I am currently pursuing my post-graduation degree from Parul University.
Excuse me, sir. Can you please enable presentation mode?
I am presenting only. I have shared my screen, ma'am.
No. The PPT, can you enable it in the presentation mode, as in the entire screen of your
Okay,
slide?
okay, ma'am. Sorry, sir. Okay.
Yes, sir.
So my title is a review on framework for detection and prevention of email phishing attack. Okay. I have reviewed my topic, email phishing attack, how to prevent and detect it. So what I have found is that email phishing remain as one of the most significant cybersecurity threats, where attackers use deceptive techniques such as impersonation, malicious link, and social engineering. The traditional security system struggles to detect a sophisticated phishing attack, where modern frameworks integrate machine learnings, deep learning, and artificial intelligence, which uses these models to identify the threat. This review is evaluated on detection and prevention techniques, their architectures and research challenges, what they face, and what are the research gaps in it. So, as an introduction, the email phishing is primary communication medium and a major target for cyber criminals. Phishing attacks aims to steal sensitive data such as password and any financial information of any organization or any entity. The rise of we are showing that there are organizations which are using cloud computing, where they store their organization data and remote, and also many employees work as a remote work also. They has expanded their attack surface. Traditional email security solution are insufficient against this evolving attacks. So the objective of my study is to analyze the existing phishing detection and prevention frameworks, to evaluate traditional machine learning and AI based approaches. Third point, to identify the strength, limitation, and research gap of the models. Fourth point, to highlight future research directions in cybersecurity in email phishing attacks. This is the framework of email phishing attacks detection. First, we gather the email data. What is it mean? We collect the raw data of email of any organization or any data sets to train first the model, to train the model. Then the data goes into data pre-processing and normalization, in which it removes the null data which has a zero entry, and then it goes to the feature extraction and it represent as the clear data, and we train the models using that features data. Through that we get train the model and we classify the which are the fake emails and which are the proper emails. Through fifth point is we get the responses and the mitigation of the framework. There are structural component, architecture component. These are the architecture component of email phishing detection systems. Data, this, as I have said, it captures the incoming mail. First point, and second is the cleaning and structures of the data. In third, features extraction module, it identifies phishing indicators, and fourth is the detection engine. Classify emails as phishing, which are the phishing mails or legitimate mails. I'm sorry for the sound. Outside there is something going on. And fifth point is the response and mitigation module, which blocks or quarantines the threads. This is the architecture component framework. As I said earlier, the data acquisition, pre-processing, feature extraction, detection and classification, we use AI-based learning models and everything. First is the traditional approach that they have used in their papers. I have just on a review. First is the rule-based filtering. It detects suspicious pattern using predefined rules. Then second point is the blacklist and whitelist method. It blocks non-malicious sources and allow trusted domains. It means that if any organization have been attacked previously, it gathers that data and block that same data and allows the trusted domains only. Not it blocks the malicious domain. Third is the signature-based detection. It identifies phishing using non-signatures, non-attack signatures. Fourth is the heuristic analysis. Detect anomalies such as match URLs and spoofed email headers. And what are the advantages of the traditional method is it's simple and fast implementation only. But their limitation is ineffective against zero-day attack. Okay. And second is the machine learning based detection approaches. We use machine learning models like naive bias, SVM, support vector machine, decision tree, random forest, and KNet, K nearest neighbors. In naive bias, effect it only classify the text and spam filtering, efficient for text classification and only. In support vector SVM, effective is only effective for high dimensional data classification. And in decision tree, provides interpretable and rule based prediction. Random forest improves the accuracy through assemble learning. Through like we trained every model, we train the random forest model. It improves the accuracy of the detection of detecting the email phishing attacks. And KN classify email based on similarity measure. The KNN classifies the email which have similarity measures of if it has similar of any spoofing email, it directly blocked it. It's the advantage of machine learning is it has high accuracy and adaptability. And the second point is it detects new phishing patterns also because we trained the data through this we trained the data set. And third is the deep learning and AI based framework. There are CNN. First is the CNN, convolution neural network. Second is recurrent neural network. Third is the long short term memory. Fourth is the transform based models. And fifth is the neural language processing. The CNN it extracts structural and textual features from email content to detect phishing attacks, phishing patterns. While the RNN model analyze sequential data and understand contextual relationship within the emails. And LSTM captures long-term defenses and detects subtitle social engineering techniques. While in the transform-based model, this is the example. BRT is the example of transform-based. It utilize the attention mechanism to interpret semantic meanings and intent in email text. While the natural language processing, it identifies linguistic cues, tone, and anomalies common used in phishing attacks. These are the advantages. It automate feature extraction. It automatically features extraction. The second point is superior detection performance. It has higher detection performance than the machine learning based. These are the hybrid detection approach. Hybrid detection combining one or two models. Hybrid means the combining of multiple models. It combines traditional and intelligent techniques, provide multiple layer security, improve detection accuracy, and reduce false positive values. It is suitable for real world applications also. Hybrid detection approaches. So how we can prevent email attacks? First is this through sender policy framework. The sender policy framework means if we send a mail through anyone or any organization, first it check if the sender has an unique take the IP address also, whether it is suspicious or not. Sorry, whether the IP address is suspicious or not. Second is the domain key identified. It sends the mail, but it encrypt the file also, and only the sender and receiver knows the file passwords. So is check whether the file has been manipulated between the sender and receiver or not. Through this, we can easily manipulate the attackers. Third is
Excuse me, sir.
yes, sir.
Reminder that you have crossed 9 minutes.
Yes, ma'am.
Please conclude your presentation.
Okay, ma'am. The third point is domain-based method of authentication, reporting, and conference. Fourth is the user awareness and training, and fifth is the real-time alert system. These are the challenges and the research gap which have been found in the models. The high computational requirement of deep learning models are there. Lack of large label data sets, limited expandability of AI models, difficulty in detecting zero-day phishing attacks, need for real-time scalable solutions. The future research direction through this, we can develop an expandable AI. Second is integration of NLP and transformation model, cloud-based and real-time detection system, hybrid intelligence security frameworks, enhanced user awareness, and cybersecurity training. What I would conclude is that email phishing remains a critical global cybersecurity threat. Traditional techniques provide foundational protection but lack adaptability. The third is the machine learning and deep learning significantly enhance detection accuracy. Fourth, hybrid and AI-driven frameworks offer robust and scalable solution. And fifth is the future system must be intelligent, adaptive, and explainable. It must adapt to the new threats also. Thank you, ma'am. Hello.
Reena ma'am, any questions?
Yes, ma'am. Yes. Nice presentation, Morvin.
Yes, ma'am.
Yeah, you have selected nice topic because we can see now there are so many attacks and which will violate the privacy and security of our confidential data. Okay, so my question here is, can your suggested framework be integrated into existing enterprise email systems for real-time detection?
No, ma'am. I have not suggested the framework. These are the I have done a review on the research paper which they have done already research, which they have some research gap also. I know after
Yes, yes.
yeah,
So,
we can attempt expandable AI. Through that, we can
mhm.
easily detect the phishing attack, which is easily usable in real time world also.
Okay. So as of now, you have done survey. Okay.
Yeah,
So
this is survey
whichever
only.
gaps, yeah, so whichever gaps you have identified, and based on that, you will be suggesting that, ideal framework that if this can be implemented, it might be helpful to, uh, prevention of the email phishing.
Yes, ma'am.
Okay.
Yes.
So, if it will get implemented, so, uh, how much percent of assurance could you please give here, uh, just as a random
Yeah,
figure,
ma'am.
okay, as per your survey?
I have,
So
ma'am.
that will.
I have done the research.
Mhm,
I have
mhm.
also implemented the every pattern and trained the models also, which currently I am getting 85% accuracy of that model.
Okay.
Yeah,
Mm-hmm.
because it's my research topic. This is only the first paper I of review, which I am currently pursuing master. So I need to publish two paper. This is my review, and the second will be my research paper also. That's I have done
Okay.
also
So
the research on. Yes.
okay. So at the level of PG only you are doing this, So this is really appreciating. Okay. And wish you all the best. Hopefully that your proposed model to, reach the accuracy of 80 to 85 to 90% for
Okay.
sure. Okay.
Okay.
So yeah, thank you very much.
Thank you, ma'am.
Yeah.
Ma'am, can I leave now or I have to stay here?
Over to Dr. Prashant, sir. Over to
Prashant
you,
sir,
Prashant.
all right. Morveen sir, please stay till the end of.
Okay, okay, ma'am. Okay,
Huh.
ma'am.
And lastly, I would like to call one last time Vedant Khade. Please try to share your screen. Vedant, sir?
Vedant, can you listen?
Yes, ma'am.
Yes, please share your screen. Vedant, are you there?
Yes, ma'am.
Yes, ma'am. Yeah. Please share your presentation.
Ma'am, PPT is not visible. Zoom workplace.
Sir, since we are on a time constraint, I request you to share your presentation recording to us later. We will consider that.
Okay, ma'am.
Yeah.
All right. Um, so with this, we are done with the presentations. I sincerely thank our authors for their excellent presentations and contribution in the session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. And we will be happy to have you in the 12th version in 2027. All the presenters will be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTIS 2026. I would also thank our session chair, Dr. Prashant Suryavanshi, for chairing the session. I am sharing a token of appreciation on behalf of the team, sir. And if you have any concluding remark for the presenters, please let me know. I would also thank Professor Reena Satpute for her valuable presence as a session chair. Thank you, Reena ma'am. I'm sharing a token of appreciation on
Yeah.
behalf of Team ICTIS and Global Research Knowledge Foundation and partners. And please share
Yeah.
any concluding
Thank you,
remark
Team
for the
G.
presenters.
About closing remark, simply I would say here all the presentations were wonderful. All authors were prepared well, and they have started preparing their mindset for the research and innovation. That is very happy to know here. And here with a formal conclude, I would be thankful, sincerely thankful to GR Logistic Foundation team again for giving me this honor and opportunity to be a part of such a global um, researchers and innovations here. So thank you very much. So
Thank
here
you very much,
I
ma'am.
can conclude, that formal presentation for virtual room G is over.
Yes, thank you, ma'am.
Yeah.
And lastly, I would request everyone to please turn on your cameras for a quick snapshot of this virtual conference. All right, thank you, everyone. Have a great day ahead and stay safe. Thank you.
Yeah. Thank you very much.